Hello there, this is an Algebra 2 video. It's Chapter 5, Section 5, Solving Polynomial Equations. And we do have 6 examples to get through today, so I will try to get through them as efficiently as possible, but please don't shoot me if the video seems a little bit longer than the norm. So the first thing I want to do is remind you, or not remind you, but give you some formulas. When you solve polynomial equations, our goal is to factor them first and then solve them like you would a quadratic. In other words, you separate the factors, make them equal 0, and then solve for x. So the first 5 examples of our lesson today are going to be all about factoring, because with polynomials, you already know how to factor quadratics, but with polynomials that have more than 3 terms and stuff, there's a couple of different ways that you can factor them. So one of those methods is up on the board right now. It's the sum and difference of 2 cubes. So that's basically when you have a to the third power plus b to the third power, or a to the third power minus b to the third power. And when you factor that, this is a formula, so it's always factored. So it's important that you identify what a and b are. Remember that just like with the difference in sum of 2 squares, you don't want to attach plus or minus to the a or b value, because the positive and negative situation is already computed as part of the formula. And that being said, what I have here on the board, it says SOAP, is basically an acronym to help you remember how to factor them, because basically both of these have the same factorization with the AB and the A squares and the ABs and the B squares, but the difference is the signs. So what this is saying is, for the red here, is that the first set of parentheses always has the same sign as the original problem. So because this is a plus, that's a plus. This is a minus, that's a minus. So same sign for the first set of parentheses. Then you always have a squared here. The second sign is the AB sign, whether it's a negative AB or a positive AB. And that is always opposite of what it was in the original. So this is a plus, this is going to be a minus, this is a minus, a plus. And the last one is the plus b squared. And in both cases you get a plus b squared. So basically the AP stands for always positive. So the SOAP acronym helps you remember that when you're doing the sum and difference of 2 cubes. So we're going to start here with how to do this. And of course, like I said before, we're just going to be factoring right now. We're not solving just yet. And as you know, there are numbers that cannot be factored, like the number 5. And we call those numbers prime because it means that they can't be factored. So likewise with polynomials, if the polynomial cannot be factored, then you write that it's prime. And so hopefully you know what that is all about. So in the first case, like I said before, one of the things that you want to do is factor out anything they have in common first. So for example, here I consider that both of these terms have an x, and both of them are divisible by 8, I believe. So I'm trying to find, not sure one for my calculator, sorry. It appears that somebody has borrowed it. Sorry about that. But anywho, so before I even get started, and this is the goal for you too, before you start trying to do anything with the difference of 2 cubes and stuff, because you can see that it's a plus and there's 2 terms, is to try to reduce this. So I notice these numbers are both even, so I'm going to take out a 2 and an x. And when I do that, I'm going to get an 8, because 2 times 8 is 16. And I'm going to need x cubed, because x times x cubed is x to the 4th. And then 2 times 54, or 2 times, not 54, but 27. 2 times 27 will give me 54. And then I have an x, so that'll give me the x, and then I need a y cubed. Alright, so the first thing I want to do is try to factor out the greatest common factor first, which in this case happens to be 2x. Now, as I look at the result, just inside these parentheses now, I can actually see some perfect cubes. Perhaps you're not aware of them, but 8 is a very common perfect cube, and so is 27. 2 times 2 is 4, and 4 times 2 is 8, so 2 to the 3rd power. So I'm going to say that a equals 2x, and b is going to be 3y. And that's because 3 times 3 is 9, and 9 times 3 is 27, so 3 to the 3rd power is 27. Notice that I also included the variable, because when I say that I want a cubed plus b cubed, I am going to cube both the 2 and the x, both the 3 and the y, and when I cube the 2, I get 8, and when I cube the x, I get x cubed. When I cube the 3, I get 27. When I cube the y, I get y cubed. So that's what I mean by it's important for you to identify what a and b are. Okay? I notice I didn't attach any positive or negative to it. It's just a equals 2x and b equals 3y. So now, according to my formula, my SOAP formula, I am going to have my 2x is already out here, and that's because it was already there before. But my first part of the formula says to do a plus b, so I'm going to get 2x plus 3y. So I have the same sign. My second step is going to be to take a squared, that means 2x squared, and that means you have to square the 2 and the x, so there's my a squared. My next sign is going to be a minus because it's always the opposite of this guy. So then I'm going to get a times b, which is 2x times 3y. And lastly, I'm going to go plus b squared, and b is 3y squared. Okay, now all I have to do is simplify my results. So again, I'm going to bring down my 2x from before. Here's my a plus b. And when I square the 2, it becomes 4x squared. I'm going to multiply 2 times 3 is 6. I'm going to get 6xy. And then I'm going to square the 3 and the y. So 3 squared is 9 and y. And this is my factored form for part A. I get 2x times 2x plus 3y times 4x squared minus 6xy plus 9y squared. Sorry, there's my 9y squared. All right, so that is how I do that. When I look at part B, it appears to be a sum of 2 cubed. I got y cubed and x cubed. But as I look at the 8 and 5, 8 is a perfect cube, but 5 is not a perfect cube. So there's not really anything I can do here. They don't have anything in common, so I can't take out an x or a y. 8 and 5 don't have anything in common, so basically this is prime. Okay, so now we want you to try these examples, and then we're going to give you a summary here of the different techniques that you can use for factoring. It might be helpful to some of you. Any number, basically the techniques are dependent on how many terms you have. So this top one will actually work for any number of terms, and that's basically looking for the greatest common factor, which is what I did by taking out the 2x in the previous example. But I also have an example down at the end that can help you understand what that means. And then you have, what if there's 2 terms? And when there's 2 terms, there's a couple of different options that you can look for. Is the difference of 2 squares, the difference of 2 cubes, or the sum of 2 cubes. And we have those formulas there. And then of course you have your quadratics that we've done in the previous chapter when you have 3 terms, ax squared plus bx plus c. And so in that case, you can either get a perfect square trinomial, or you can do the general trinomial, which is basically when we had the 2 parentheses and we did the little plus to factor. And then of course there's this last one, which is if there's 4 or more terms. And in that case, you want to use a technique called grouping. And I kind of have an example there how that works. But our next example is actually going to be dealing with grouping, so hopefully it'll make more sense to you there. When you group, what you want to do is basically you can't, not all of the 6 factors are going to have the same thing in common. So what you want to do is group them a few at a time, sometimes 2 at a time, sometimes 3 at a time. And in this case, I'll go to a factor of 3 at a time. So what I can see in the first 3 terms, and by the way, terms are always separated by addition or subtraction. So I have 1, 2, 3, 4, 5, 6 terms. And as I look at the first 3 terms, they all seem to have an x in them. They all have a, b, and c, but they also all have x. And the next 3 terms all have a y in them. So I'm looking for the greatest common factor between the 3 terms that I grouped together. So 8, 4, and 4. That means that I can pull out a 4. The greatest common factor will be a 4. They don't all have A, and they don't all have B, and they don't all have C, but they all have X. So I take out the 4X. And when I take out the 4X, I have to put here a 2A. So that 2A times 4X is 8AX. Here I'm going to need a b because 4x times b is 4bx. And here I'm going to need a c because 4x times c is 4cx. Then I look at the next three terms, and in a very similar fashion, I realize that they all have a 3 in common because 6, 3, and 3, and then they all have a y. So again, I'm going to need a 2 here and an a because 3y times 2a is 6ay. I'm going to need a b, so that b times 3y is 3by, and I'm going to need a c because 3y times c is 3cy. And now this is where it kind of gets tricky. That part seems kind of easy for people to understand, but what happens with factoring by grouping is that you have a factoring problem within a factoring problem. I said earlier that terms are separated by addition and subtraction. So right now this plus sign is what's separating this term from this term. Now you might be asking yourself, well, Mrs. Martinez, there's a plus in here as well. That is true. So as I look at these parentheses, you're right. There are 3 terms in there, but those 3 terms are being grouped together with parentheses, and that means multiplication times the 4x. So what you want to be looking at right now is not the fact that there's 3 terms in here, but we want to look at this as all one big unit, and it's being multiplied by 4 and x. So the only real division here between terms is the plus that's right here. So you have 2 terms now in these pink boxes. And so as you look at those pink boxes, you need to ask yourself, what is common between the 2 boxes? What do both boxes have? Just like when you look at these 3 terms, what do they all have in common? They all have a 4 in common. They all have an x in common. What do these 2 boxes have in common? Well, they have the 2a plus b plus c. They both have that same factor in there. And when you have something in common, you take it out of the box. So I'm going to take out the 2a plus b plus c, but I want to keep it all together. So I'm taking it out, so now it's gone. And then what remains in the box is a 4x. So in this box, you're left with the 4x, so that kind of goes in there. Then you have a plus from right here. And then the 3y comes from the other box. Okay? And that's actually the answer. And if you don't understand why that works, again, you can, just like here, what you saw me do was say that 4x times 2a was 8ax. It is true that 4x times 2a plus b plus c is all of this same term. And then 3y times 2a plus b plus c is all of that term. So it is in fact the same thing. So basically what you're looking for is when you've done your grouping, your first grouping, is what does they have in common? That common thing comes out, and then whatever's left is what goes in the second set of parentheses, which is the 4x and the 3y in this case. So our answer right now is 2a plus b plus c times 4x plus 3y. And that is how you do factoring by grouping. And if that was still a little too weird for you, I'm going to do another one over here in part B. And maybe the second time around will be a little bit easier. So again, I'm looking at all my terms, and I've got F, a G, and then we have a G here, and H and H. We've got some Y's. I've got 3 terms that have Y in them. So I'm looking at this guy right here. 3 terms that have Y. And then I'm going to have 3 terms that have Z. So notice that you don't have to have the terms in order to group them. So for my first group, the ones that have the Y in common, I see that we've got a 20, a 15, and a 10. All of those are divisible by 5. So I'm going to pull out a 5y. And then I know that for my first term, I'm going to have to put a 4f, because 4f times 5y is 20fy, which is this guy. And then my next one is going to be the plus 15gy, so I'm going to need a plus 3g, because 3g times 5y will be 15gy. And then in my last term is a minus 10hy, so I'm going to need a minus 2h, because negative 2h times positive 5y is negative 10hy. And that takes care of those 3 terms there. And then I'm going to go to the blue, and I'm going to see that I have a negative, and 16 and 8 and 12 all have a 4 in common, so I'm going to take out a 4. And of course they all have a z, so I'm going to take out a z as well. That means that I'm going to need a positive 4 here and an f, because negative 4z times positive 4f is negative 16fz, which is that guy. And then here we're going to want a negative 2h, and that's because negative 4z times negative 2h is positive 8hz, which is what this is. And then lastly, I'm going to need a plus 3g, and that's because negative 4z times positive 3g is going to give you negative 12gz, which is this guy. So be very careful with your negatives there. And then again, as we look at the two, this is my subtraction symbol, which separates my 2 terms. So there's one box. There's the other box. And as you're looking at the 2 boxes, what do they both have in common? They both have 4f plus 3g minus 2h. There are different orders. Here we have 4f plus 3g minus 2h, but we still have 4f plus 3g minus 2h. It doesn't matter what order it's in. So that's the common thing, so we're going to pull that out. 4f plus 3g minus 2h. And then what's left in the box is going to be 5y minus, because of this minus here, 4z. And that will be our final answer. And that is how you factor by grouping. I hope that made sense for you. And so now I would like for you to try these 2 examples on your own, and then we'll move on to the next task. Alrighty? So that's example 3. And basically at this point we're just going to try to factor in whichever ways we can based on the previous summary that I've given you. We're now looking at, in this case, 2 terms. And so what we're going to do here is we're going to be combining a difference of 2 squares and the difference of 2 cubes. Alright, now let me show you what that means, okay? X to the 6 minus y to the 6 can be rewritten as x cubed squared minus y cubed squared. Because if you recall, a power raised to a power, you multiply the exponent. So 3 times 2 would be a 6, and so that's how you get that. So what I'm looking at right now is that this is a squared minus b squared. And according to our formula from before, when you have a squared minus b squared, you can factor that as a minus b times a plus b. Alright, so if it helps, you can even say to yourself that in this scenario, a would equal x cubed and b would equal y cubed. Notice that I don't attach the negative to it, but I've got a squared minus b squared, so my a is x cubed, my y or my b is y cubed. And according to the formula, if you look back in your notes, you get a minus b, a plus b, so I have x cubed minus y cubed and then x cubed plus y cubed. And then, the reason why I said we're going to combine it is because now we can actually combine, this is now a difference of 2 cubes, and that's a sum of 2 cubes. And we have formulas for that too. So, and we're going to use our SOAP. So, in this case, it's really simple. A is x and b is y. So, remember that SOAP means the S stands for same sign. So, I'm going to go x minus y. And then I'm going to get x squared. And my next sign is going to be the opposite of this one, which is a plus. And this time I'm going to go a times b, or x times y. And then plus b squared, or in this case, plus y squared. Alright, and that's for this guy. But then you also have the sum of 2 cubes. So I'm going to do another one, and this time it's a plus. So it's the same sign, x plus y. And then you have opposite sign, so we're going to go minus xy. And then you have plus y squared, always positive. So that's basically our complete factorization for part A. If you want, You can even try to put the x minus y and the x plus y together first, but there's no need to do that. And so that will be your answer for part A. Now the bad thing is that I've kind of infiltrated the side B over there, but hopefully we can get through without too much complications. So over here, we want to look at this little guy and try to see what we can do as far as factoring. Now, one of the things that you want to notice is that you always want to try to factor by grouping first when there's like more than 4 terms. So in this case, we've got 1, 2, 3, 4, 5, 6. And I'm looking at, these all have A in them, these all have B. So I think we're going to go with A, with grouping. So I'm going to group these 3 terms together. And they all have A cubed. So I'm going to get x squared minus 6x plus 9. Since they all have A cubed, that's actually worked out kind of quite nicely. And then over here, they all have B cubed. So I factor out the B cubed and get x squared minus 6x. And again, be very careful with your negatives. Because this is a minus B cubed, then this needs to be negative, negative to make a positive 6, and negative, positive to make a negative 9. So now, as I look at my 2 boxes here, there's 1, there's 2. What do they have in common? They both have x squared minus 6x plus 9. So I'm going to take that out. And then what remains is going to be A cubed minus B cubed. All right. Now this is actually a perfect square trinomial, but again, you can factor that by using our little plus method from before. So 1, 1, 3 times 3 is 9. If we make them both negative, negative 3 times negative 3 is positive 9. And if I add the 2 diagonals together, negative 3 and negative 3 is negative 6. So they're both the same factor, x minus 3, x minus 3. So that's going to be x minus 3 quantity squared. So it's a perfect square trinomial. And then over here we have a difference of 2 cubes again. So we're going to use our SOAP, which means same sign. Then we have opposite sign. And then always positive. So at the end of the day, this will be our complete factored form. X minus 3 quantity squared times A minus B times A squared plus AB plus B squared. So now if you will try these 2 on your own, remember that if it's not factorable, you can write down its prime. And then we will go on to our next example. And I'm going to check my time. And we're doing okay. We might have to make this into 2 parts. We've got 7 minutes here to get through 2 more examples or 3 more examples. So here we go. A small cube is cut out of a larger cube if the small cube is half the length of the larger cube and the figure is 7,000 cubic centimeters, what should be the dimensions of the cube? So basically what we have to do is solve this factoring problem. Now I didn't draw the whole cube. What you see here is 2-dimensional, not 3-dimensional. But basically for a cube, what happens is that all the sides are the same. So you have, for volume, you need length, width, and height. So volume is going to equal length, width, and height. But the cool thing about a cube is that the length, width, and height are all the same. So what they're telling us is that we have a small cube inside of a larger cube. And so I've only got part of the diagram here going, but that's all we really need as long as we understand that there's 3 dimensions. And it says that the smaller one is half the length of the larger one, but you don't want to deal with fractions. So what that basically means is that if this is like 9, then it's half of the larger one, so the larger one would be basically twice or double. So if the larger one was 18, then the smaller one would be 9, which is half of that. So it's easier for us to call this x. The dimensions here x by x by x, and the larger one would just be double that, twice x, and then you wouldn't have any fractions. So basically, the small cube is being cut out of the larger one. So the larger one is 2x cubed, and I'm taking out the smaller one, which is x cubed. Remember that the dimension you don't see here is the depth. So we have length times width times height. So we need 2x times 2x times 2x, which is 2x cubed, and then of course x times x times x. And then of course larger, and the figure is 7,000 cubic centimeters. So after you pull out the smaller cube from the bigger cube, your volume is going to be 7,000. So this is basically our setup right here. It's going to equal 7,000. And then basically we just need to solve the problem. So we're going to get, let's see here, 8x cubed. Sorry, I had a little brain fart there. So we're going to, 2 times 2 times 2 is 8, so 8x cubed. And when you go 8x cubed minus x cubed is going to give you only 7x cubed. Equals 7,000, and you can divide by 7 on both sides. And then you can take the cubed root, not the square root, the cubed root of both sides, and then you'll get that x is equal to 10. All right, so that is how you do that little guy. And so what should the dimensions of the cubes be? Well, they're going to be 10 by 10 by 10. And in the case of the larger one, it would be double that, so it would be 20 by 20 by 20. All right, so that's how you do that little guy. And now we're going to have you do this example. It's the same idea, only now it's telling us that the cube is 1/3 of the length. So just a hint to you, if you make the smaller one x, then the larger one will be 3 times x. So, and then it'll be very similar to what we just did. All right, and now we have example 5. And I'm going to go ahead and cut this video here, and then we'll finish these last 2 examples in the next part.